Hey everyone, welcome to the channel. In this video, we're going to go over 35 key concepts in artificial intelligence, ranging from what is AI, how is AI made, all the way to more advanced concepts like tokenization, reinforcement learning from human feedback, AGI, and the future of AI. Welcome to Code with Simeon. Let's start from the beginning. What is AI? AI is an acronym that stands for Artificial Intelligence. It's in the name. It's basically something that is smart, that is man-made. Hence the artificial and the intelligence. It basically refers to computer systems built by humans, of course, that are able to emulate intelligence by accomplishing tasks that require natural language understanding, decision-making, and learning from experience. Basically all the things that make us intelligent humans. Since most of the technology that we have as mankind is modeled almost directly off nature, think birds and planes, think robotic arms and normal arms, at their core, an AI system is a neural network, which is a computing structure that is inspired by the human brain, just like how our brains work with neurons, and that is how we learn and how we are. Similarly, AI systems have neurons as well, just that these are digital neurons. The process of training an AI model, creating an AI model, basically involves altering and adjusting the strength of the connection between these neurons, just like how when you're learning a new language, the neurons in your mind are reconnecting, reorganizing, and realigning to store this information and to adjust your level of intelligence. The process of adjusting these neurons and creating the model is what's called training. There's various different ways of training AI models. There is ways of optimizing the training of an AI model, but I do not want to get into that right now. It's a whole can of worms, trust me. It's a whole thing. But the general gist is, what these researchers do is they gather a lot of data, the data that they want to train the model on. For example, if it is a text model, like how you see ChatGPT, they get a lot of text, like a lot. Actually, recently, OpenAI was in a lot of hot water with lots of companies because they claim that OpenAI stole their data to train their models. Actually, here's an honorable mention. Is it honorable or honorary? Here's an honorable mention. A couple of months ago, back when Mira Murati was still the CTO of OpenAI, she was in an interview with an interviewer from the Wall Street Journal, and she was asked about where they get the data for training Sora on. Sora is the video generation model by OpenAI. Check out the interview, check out this clip.
What data was used to train Sora?
We used publicly available data and licensed data.
So, videos on YouTube?
Help me! Help me!
I'm actually not sure about that.
Bruh.
Okay. Videos from Facebook, Instagram?
You know, if they were publicly available, publicly available.
Oh my God!
To use, there might be the data, but I'm not sure.
Yeah.
I'm not confident about it.
What?
What about Shutterstock? I know you guys have a deal with them.
I'm just not going to go into the details of the data that was used, but it was publicly available or licensed data.
And that actually further compounds the statement that data is the new gold. In order to train a text model like ChatGPT, one needs a lot of text. This text needs to be broken down into tiny chunks of information that the model can then be trained on. This process is called tokenization. Think of a token as a piece of information. For a text model, a token could be a word. For a video model, a token could be a frame. For an image generation model like Stable Diffusion and the likes, a token could be a pixel on the screen. So you need to envision these AI models as token generation machines. It could be anything. You could train an AI model whose tokens are a robotic arms movements. But in order to train such a model, you would need a lot of this data to train the model on. Currently, the most popular form of AI is large language models. Think ChatGPT, Claude, DeepSeek, the likes. Basically, what these models do is they predict the next output token given their training data, given what's in their context window. I'll get to that point later, I'll get to that concept later, and given your prompt, like for example, what is a cat? Based on this information, they then predict the next token is A. Then based on the A that it has predicted and all the rest, they then predict that the highest probability of the next token is going to be cat. So a cat is, and then they just keep doing that. So in essence, AI is just lots of statistics and math, tons of math in there. That's how they work. It's probability at its finest. Actually, there's a website that I stumbled upon as I was editing this video that just properly demonstrates how AIs work. It's the best visualization I've seen. Let me pull it up real quick. You can see here the site has two halves. The first half here shows a cube. This cube represents the AI's mind in semantic space. Then on the right side here we have lots of text. I'm going to show you what each of these things does. So every single dot that you see in here and the paths connecting it represents a connection between a word or a concept. As you can see, when I just hover my mouse over these things, the thing changes on the side here. So let's say you ask the AI, like you prompt it, what's the best thing about AI? And then the AI starts the sentence with, the best thing about AI is, then it proceeds from there. So what we're going to do is I'm going to move the mouse and hover it over this, and you notice that as I move the mouse, the words that I select, the words that I choose get typed out on the right side up here, and also the paths that have been chosen within the digital mind here get updated as well. So I'm just going to type out a sentence. The best thing about AI is its ability to... Now notice that some words are bigger than others. The ones that are bigger are the ones that have the highest possibility of being chosen. They are the most probable token. So if this was an actual AI choosing, it would choose, there's a higher chance of it choosing perform, process, learn, and analyze over it choosing unearth or outperform. And this is determined by the training data that it was given when it was starting, like when it was being built. So it goes, the best thing about AI is its ability to learn and adapt quickly to new tasks. Let me switch to tasks. Now let me choose something which just one of the unexpected ones. Tasks. This enables it to so you see how as I choose the words on the right, on the left side here, they keep showing, they keep typing, and in the model the paths, the connections just keep... Wow. As you can tell, I was about to start nerding out. I'm very impressed by this website. It's just such a good visualizer. And I can click on a path and I just choose that, just fix it in time, and my god, it's such a good website. Anywho, yeah, that's it. That's the site. So I'm going to provide the link to this site in the description, and you can visit it at your own pace. I didn't make it, some other dev did. His name is Santiago Ortiz. Just very well done. Actually, you can change it to a different prompt on this site. Let me choose one which uses his name, Santiago Ortiz. And he adds in here that yes, this is a self AI. What I found interesting is that it's approximately 50% truth and 50% BS. It feels like it describes alternative versions of myself in the multiverse. Such a good passion project. So Santiago Ortiz is a data visualization designer and founder of the website and platform Truthy Digital. He is known for creating visually stunning and interactive data visualizations for his innovative and creative approaches to visualizing complex... It just keeps going. It's a whole thing. Such a good website. Highly recommended. Check it out in your free time. And I'm done recording this segment. Let me explain the concept of a context window. The context window is the range Oh boy. The context window in an LLM is basically like its RAM. That's how you should think about it. And if you don't know what RAM is, let me break this down even more. So imagine you want to paint, you want to do some stuff on your table, right? So in one corner of the table you open a book which has your notes. In the other corner of the table you put your paint brushes, you put your cans of paint. In another corner you have your cup of water. You get the table in this analogy is your context window. It's how much space you have to work with. Beyond the context window of an LLM, it doesn't work as expected. Different AI models have different context windows. ChatGPT has 128,000 tokens that it can take in its context window. If you're taking a word as a token, which it's not really a word a token, but like it's approximately one word a token. So if you're taking a word as a token, that's 128,000 words that can fit in the context. This is between your messages and ChatGPT's messages. Only 128,000 messages can fit in that conversation. So there is tricks to this. You can have another LLM when the context window is getting beyond a specific limit and the conversation is getting too long. There's a trick where they can use another LLM to summarize huge chunks of the conversation, so that when you're feeding this back into the context window for the LLM to understand what you're talking about, it doesn't fully lose everything that you've been saying, but it retains the general gist. There's tricks around it. It's a whole thing. Anywho, ChatGPT currently has a context window of 128,000 tokens. Claude 3.5 Sonnet and Claude 3.5 Haiku. Actually, all the models by Anthropic, all the way from Claude 1 and Claude 2, they have a context window of 200,000 tokens. The highest context window is Google Gemini, with 2 million tokens, that is Gemini 2.0. But a couple of days ago, a new model got released by Minimax, the ones that made the Minimax Video Gen model. It's actually very good. And their model, the Minimax 01, has a context window of 4 million tokens. So, yeah, let me put this into context. The entire Harry Potter book series is about 1.1 million words. So, with a 4 million token context window, you could fit the entire Harry Potter book series, like all 7, are they 7 or 8? All 7 of them 3 times. That's how much context window that is. And previously, context window was a limitation for AI advancement, but with the trend of things, the context is not going to be an issue. The issue is hallucinations, which brings me to our next topic, hallucinations. Hallucination is when AI models lie about something, but they lie with such confidence. And that is one of the biggest boons of AI models. Hallucinations are usually observed on topics like mathematics, logic, and advanced science questions. Let me show you an example of a hallucination in practice. I'm on the DeepSeek chat website, that is chat.deepseek.com, and I'm going to ask DeepSeek, how many words are in your response to this question? Then I'm going to submit, and you will see that it says it has 10 words. So let's count the responses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's more than 10. But it's very, very confident on this. And even if I ask it to try again, it will still fail. It says the response contains 8 words. 1, 2, 3, 4, 5, 6, 7, 8. Even if you count the dot as a word, they're not 8. So this is a hallucination. It is so confident with its wrong answer. And I don't blame it. This is a problem that it's inbuilt. It's in how LLMs today that are built of the transformer architecture work. But there is solutions to this. One of the best solutions to hallucinations today is chain of thought reasoning. Actually, another word that they usually use to refer to it these days is test time compute. But I mean, I feel like the word test time compute it's wasted. I prefer chain of thought reasoning. So I'm going to create a new chat with DeepSeek, and this time I'm going to enable DeepThink. So what this does is I permit the model to take some time thinking. So it's called a reasoning model. So when you give a model time to think, usually the results are better, but the costs are higher. It's similar to how you can ask someone a question, like for example, what's 2 factorial? And they tell you the first thing that comes to their head, which is like 6. It's not correct. But then again, you didn't give them time to think. But if you give them the question, then you let them think about it and come back a few minutes later, a few hours later, a few days, weeks, months later, they will have a good answer for you, and chances are higher that the answer will be correct. That's basically what this is. I want to ask DeepSeek with DeepThink Tandon, how many words are in your response to this question? Then let's see what it says. So as you see, it thinks for a bit. It says, okay, let me see. The user is asking how many words are in my response. I need to figure it out first. I need to make it so I understand. Wait, but there's a catch. The number of words in the response depends on the number itself. So you see, it's thinking for a bit. And it's nice that the reason why I chose DeepSeek for this is because they actually let us see the thinking tokens, which is this. If I was to use ChatGPT's O1 or O3 model, you just see thinking, then the final answer, which is BS in my opinion. So it says there's 7 words in the response. Let's count them. 1, 2, 3, 4, 5, 6, 7. I'm not counting word count 7. Okay, come on, you know. 7 words, correct, while it failed previously. So this is one way to fight hallucinations, chain of thought. But keep in mind that this makes the model slower, and it also makes the model more expensive. So that's the trade-off. You have to trade off speed versus quality, expenses versus quality. So I'd not recommend turning on this DeepThink, these reasoning models, unless what you're doing really requires reasoning. For the highest percentage of daily tasks, basically everything that you use ChatGPT or whatever for, it doesn't need DeepThink. It doesn't need a reasoning model. A normal model can do it. Before I move away from the concept of hallucinations, there's another concept that I need us to cover, which is the concept of temperature. This is not something that you as a regular user of AI and like ChatGPT and whatnot would adjust. This is something that's purely for the developers that make systems that integrate these AI systems. They integrate these AI models. The temperature is basically how creative or how prompt adhering your model is. Now, I'm choosing peace, and I'm not going to delve too deep into the topic, but the general gist is the higher the temperature, the more creative and the more erratic your model will act. The lower the temperature, the more prompt adherent, but the less creative your model will be. So the safe spot is usually a temperature of 1. You will see this slider on any playground or any AI editing console, workbench. They name it different things depending on the provider, but yeah, that's generally it. This concept will come in handy later on when we are actually building AI powered systems on this channel, but for now I'm stopping it here. The training of these models happens on specialized computers called GPUs. These are graphics processing units. GPUs have a whole different way they process data from the conventional CPU that you and I use, a CPU that is in your desktop, your laptop, your phone. CPUs are designed for sequential processing. They basically have a few powerful cores, like 4 to 32, that are optimized for complex decision making and varied tasks. GPUs, on the other hand, are built for parallel processing. So basically, it's like the difference between having 1 or 2 very, very highly skilled workers and having 1,000 less skilled workers. So if you daisy chain these GPUs together, say 600,000 of them, and you just connect them, you have a ton of processing power and you're able to do very advanced calculations. GPUs excel in tasks that can be broken down into many incidental operations like graphics rendering, matrix multiplication, which is why NVIDIA stock is just soaring right now, because they are the leading producers of GPUs. You know how when you're chatting with ChatGPT and then you ask it a question, then it gives you a message. There's a tiny thumbs up and that tiny thumbs down thingy that is like in the bottom right or bottom left corner. And then like when you click on it, it lights up, and then you just keep chatting. Then you send another good message and you click on it. That's you assisting to train the model. Another good example of this is Midjourney. Okay, I'm pausing it a bit here so that you guys can see this shit, because The Midjourney homepage is a masterpiece. I mean, look at this. God damn. Midjourney is the king of this. In Midjourney, when you ask it for an image, they give you 4 options. Then you just click on one, the one that you want. And then on that one, when you give it another prompt to generate another image after that one, then it gives you 4 options as well. So every time that you choose an option in Midjourney, the system knows, and it notes the differences between the one that was chosen and the ones that weren't. And based off your choice, it learns, and this data is used to make the model itself better. It's a very efficient way of making your systems better. This constant collection of data from humans as they use your AI model, this is what's called reinforcement learning from human feedback. So based on the humans that use the system, you get their feedback, and then you reinforce good traits into your model. Now, the data that it takes to train an AI model is immense. So what these AI companies were doing was they were scraping everything. I mean everything. They scraped Wikipedia. It's basically been shredded at this point. The fact is, every single piece of data that's on the internet, all your tiny blogs, your personal portfolio website, your YouTube videos, your TikToks, whatever it is that is out there on the internet has been scraped and used to train an AI model. Which is why around the time when this whole AI thing was just starting, Elon Musk did a 4D chess move and locked down the X platform. So other AI companies were not able to access X's data and use it to train their models. The logic behind this is X right now is a source of very, very high quality human data. Like, people are posting on X all the time, like all the damn time. Facebook is another source of very good, high quality, rich data. And Meta knows this, which is why they use that data to train their models, and then they open source them, which is a very good thing. I'm going to go to the concept of open source later. Reddit was another source of very good, high quality data. Right now, Reddit is partnered with OpenAI, so that data is going there. Now, when everything has been trained on, when all the human data has been used, what else is there to use to train the models? Well, why not use an AI model to generate data to train an AI model? That's the concept of synthetic data. The problem with synthetic data is AIs make up a lot of things. So the data that AIs generate may not be that high quality, which is where data annotators come in. But that's a whole other thing. I don't want to get into that one right now. But the general gist of data annotators is there's people that are paid to look through data that's going to be used to train an AI model and to mark it as either high quality content or low quality or bad. So that's a whole other thing. Synthetic data is actually becoming more and more viable right now because models are getting more and more intelligent and smarter. So the chances of them producing very poor quality data is slim. So much is going on in the world of AI. Model distillation is basically when you get a more powerful model, a teacher model per se, to distill a smaller model. In the simplest of terms, model distillation is how you can get a smaller neural network to mimic the abilities of a larger neural network through specialized training methods. So you don't have to expend all the resources that you went through to train the larger one. You just distill the abilities of the larger one, including natural language processing, all the reasoning, all the intelligence, everything just gets basically, it just trickles downwards to the smaller model. That's the easiest way of putting it. So when you see that there is GPT 4o and then there's GPT 4o mini, 4o mini is a distilled version of GPT 4o. Similarly, Claude 3.5 Haiku is a distilled version of Claude 3.5 Sonnet. Inference is the process of running the model. This one is a bit easy. It's a bit on the nose. When someone says that they are running inference on a specific model, it means they are prompting the model and getting results from it. Now let's get into the key terms involved in the actual use of AI. Let's start with prompt engineering. Prompt engineering is the art of telling an AI exactly what you want it to do. Yeah, that's basically it. You tell it in exquisite detail what you want it to do, because as I mentioned earlier on, AIs make up things. A good example of this is, instead of telling Claude, write me a poem, you tell Claude, write me a poem about my workmate Becky, who wears a yellow dress and likes flowers. That's a better prompt right there. And there's a higher chance that Claude will give you a more relevant result. Prompt templates is basically templates that you can fill in to craft your prompts. There are templates out there for basically every kind of prompt. Let me give you guys a quick example here. This template is a document that I got from HubSpot. I want to fill in anything, random detail like MTN Uganda. So the whole prompt says, design a product launch campaign for MTN Uganda that generates excitement amongst the youth of Uganda, highlighting how our new offerings, cheap prices, solves their need for cheaply priced internet. Then I'm going to copy the entire prompt and I'm going to switch over to DeepSeek, the chat.deepseek.com website. I'm going to paste the prompt in there, press enter. Then DeepSeek quickly follows the prompt, writes out the template properly, and before it even finishes, I'm telling it to turn this into an email. So once it's done writing whatever it has written, and I'm going to tell it to address the email to MTN Uganda Head of Marketing. His name is Patrick Salvador. His email is salvador@gmail.com, and make it sound enticing. Then I submit. Then the AI writes the email for me. Keep in mind, by the way, that you really need to read through these things that you AI generate, because these days people can tell that something is AI generated. So anywho, so I'm changing the name to Mariachi, then a person writes. So this has all been possible because of that one template. Aside from the template, filled in the blanks, put that prompt in here, and I'm using it to do great things. To run these AI models, you need a very, very powerful computer. Think basically a supercomputer. Though these days there's small language models that you can actually download and run on your laptop. That is models in the 1 billion to 7 billion to maybe 8 billion parameter range. You can run a 14 billion parameter model on your PC like the recent 5.4 by Microsoft, but you would need a very strong PC. I'm talking 64 GB RAM and above to run that. A 7 billion parameter model can comfortably run on a 16 GB RAM PC, no problem. So anything 7 billion and below, you can run. But now, all the good models, like all the most powerful ones, are 70 billion parameters and above. Recently, Meta released Llama 3.3. It's a 70 billion parameter model and it is so good, but you can't run it on your PC. Your PC would basically explode. Your PC would just... ChatGPT, Claude 3.5 Sonnet, all those are closed source models, so we don't really know how many parameters they are. But from the open source models that compete with them, we can have a general understanding of how big these models are. The closest competition to ChatGPT and Claude 3.5 Sonnet right now is DeepSeek v3, and this is a 600 billion parameter model. Before DeepSeek v3, we had Meta's Llama 3.1 405B. That 405B is 405 billion parameters. Don't try running that model on your PC. It's open source. You can download it right now if you wanted to, but you can't run it on your PC. It can't. Your PC just wouldn't. So in order to run these big models, if you wanted to access the capabilities of these powerful models, the models have to be running on someone else's computer, and then you can run inference on these models using an API. So most of these companies, like OpenAI, Anthropic, the makers of Claude, Google, the guys that make Gemini, all those, they offer APIs and then they sell tokens. So you ask the AI, hey, what is this? Then via the API, the AI responds to you, and then you send the response back plus the chat history. So via that API is how you're able to access these advanced models. Now, based on your token usage, based on how much stuff is being sent, how much stuff is being received, the companies bill you. It's business. The next topic is multimodal AI. Think of a modality as a type of data. The original ChatGPT couldn't accept images. You could just type, it responds with text. You text it again, it responds with text. The only modality that it could accept was text. The next iteration of that could accept images. So you could upload an image, then it responds, and you could do that. Google Gemini is the most multimodal model right now because it can take text, it can take voice, it can take videos, especially those on YouTube, but then again, I'm calling BS on that. I don't think it fully understands the video. I think it just gets a transcript, but we're derailing. The general gist of modalities is basically every sensible AI model right now can take text and images. Only a few can take sound. For example, GPT-4o is able to input images and sound and text, and it can output text and sound. And this was actually one of its biggest selling points, the voice output. Before GPT-4o being able to output sound, we had GPT-4 Turbo, and the way the voice mode in the ChatGPT app was working is that you would say hi to the model, and then your hi would be sent to an API of a service like Whisper, or I think it was Whisper. Whisper is by OpenAI as well. Then Whisper converts your voice into text. Then that text is sent to the AI model. The model then gives a response. Then that response is sent to another model that converts that text into sound, and that's sent to you. So the user experience of that is about a 2-second delay between responses. So you'd be like, hi, then the model checks sometime and replies like, hi, how are you? Another key thing to note about such an implementation is that the user is not able to interrupt the model when it's talking. So when you say hi and it wants to reply with a paragraph, you will listen to that paragraph unless you just stop the whole thing and exit ChatGPT. So no matter how much you say, stop, please stop, I made a mistake, no, it will just keep yapping. In contrast to the advanced voice mode that we have today, where you say hi and it responds immediately and you are actually able to interrupt it. Being able to interrupt the model is a good way of knowing whether or not it's truly multimodal. Currently, if you have an Android phone, you can long press the home button to open your Google Gemini assistant, and then there will be a tiny voice icon in the bottom right corner there to activate Gemini Live, which is Google's response to advanced voice mode by ChatGPT. And you will see that the conversation feels more natural because when you talk to the model, it responds almost immediately, so there is barely a delay in between there. So basically, when you interrupt the model by saying stop, your stop goes directly to the model itself. Welcome to the world of multimodality. Now, let's talk about the AI ecosystem and considerations. Let's start simple. Open source and closed source models. Companies like OpenAI, Google, Anthropic are famous for being closed source. Actually, the biggest joke there being OpenAI, because the name Open, because when Elon Musk was creating the company, he says he purposefully named it OpenAI so that they can create AI and open it to the world. I think they should just change their name to Closed AI. Anywho, open source models are models whose entirety is published to everyone. So they spend millions of dollars training these AI models, then they release everything to the public. They release everything to the developers, and you're free to use it as you wish. You can tweak it as you like. It's entirely up to you, and you do not need to pay them a dime. That's open source. Previously, open source models have been lagging behind their counterparts, the closed source models. Models like GPT-4o, Claude 3.5 Sonnet, O1, and the likes. But recently there has been a serious paradigm shift. There's a Chinese company called DeepSeek that released a model called DeepSeek V3, and it is the first open source model to be as good or better than the closed source models. And this fact took everyone in the AI community by storm. A couple of days ago, they released a new model called DeepSeek R1, which is one of those test time compute like O1 by OpenAI, O3 by OpenAI, and the Gemini DeepThink model by Google. This is an open source model that rivals these. So that's where we are now. Frontier intelligence, available to everyone. Personally, I'm all for open sourcing. If it's been done, release it to everyone and let everyone have access to it, then let's see what we make. Now look, there is some risk to open sourcing some technologies, but then there is some whereby closed sourcing it is pointless. For example, if you close source a text generation model, why? Open source is going to catch up either way. Closed sourcing a protein generation model like AlphaFold, that one makes sense because technically someone could use this model that can generate all sorts of proteins to generate some biochemical weapon because they could, unless there is severe, like properly implemented, what are they called, guardrails into the model, maybe there. But a video generation model, why would you closed source that? People need to be able to create stuff, and closed sourcing it is pointless because open source will eventually catch up. It will take a while because open source projects usually have less funding than closed source projects. Like, OpenAI has billions to work with. Open source projects have just a couple millions, but they will still get it done and it will still catch up. So yeah, it's a sensitive discussion, it's a sensitive topic. When these AI models are released, humans need a way of knowing how intelligent the model is because intelligence is quite hard to test. An example of this is academia. Your teachers put you in a class, they teach everyone the exact same way. Those that want to learn more go and learn more, and then at the very end, you all sit the same exam and you see who performs the best. That's basically what these benchmarks are. Whenever a new model is released, there are specific benchmarks like MMLU, HelaSwag, which is basically a ton of very, very hard and very complex questions that humans would usually struggle with. And these questions are fed into the AIs to test how good the AIs are based on how well they score on these benchmarks. Currently, where we are right now, most humans on the planet cannot handle the questions in these benchmarks. Like, they are very hard. And the AIs are squashing them. It's ridiculous even. And they're only getting smarter. This is like the new worst it can be. Which brings me to the next topic, AGI. But I'm saving that one for last. The next thing that I want to cover is bias. Now, as I mentioned earlier on, these AI models are trained on a lot of data. The data that the AI is trained on basically determines a lot of things about the AI. They inadvertently give these AIs a sort of personality. A good example of this is Google Gemini. A couple of months ago, Google was under a lot of pressure and a lot of public scrutiny when their model was trying to be woke. Let me first give you the tea real quick. Right now, if you try to generate an image of a human being using Gemini, it will say, sorry, can't generate images of people. This is only available to people who have paid for advanced Premiere Pro or what. But like back then, you could generate images of people using Gemini when they had just rolled out the image generation feature. And when you try to get an image of some culturally specific thing, like generate an image of the founding fathers of the US, because of how Google trained the model to, and they tried to fight the whole bias thing, they tried to make it woke and appeal to everyone, it would generate black founding fathers or black Vikings, Chinese Vikings, probably Mexican conquistadors. It was a whole thing, and so much noise was made all over the internet because of it. So yeah, they fixed it. Obviously, they rectified it, so you can, if you go to ImageFX, you can generate images of humans and they will not be all mismatched in their colors. But yeah, that's what happened. Now, bias can be a problem if, say for example, you're training an AI to hire people, but in the data on which the AI was trained, there's basically zero women representation whatsoever. So that means that this AI, there's a very high chance that it is going to discriminate against women, and it's not its fault, it's the fault of the bias in its training data. And the problem with this is most of these AI models that we use today are so advanced, they're basically black boxes. It's hard to go in and tweak specific things. Anthropic AI has been doing a lot of progress in this. Their research is called mechanistic interpretability. It's a whole thing. I don't want to get into that right now, but Generally, they are unraveling the mind of AIs in order to fight such biases and to ensure alignment, which brings me to the next topic: alignment. Alignment is one of the most important concepts in AI. Actually, let me enable serious mode for this.
A few moments later.
AI technology has the potential to do so much good, so much. It has the potential to revolutionize entire industries and change our way of life, as it already has. I'm sure by now you can tell. There's so much going on in the field of AI, it's crazy. But then again, it could go wrong, like so bad. It could end everything, literally everything. Alignment is a concept in AI which basically entails making sure that the AI systems that we are building are aligned to our virtues and to our norms and to our beliefs as humans, and ensuring that the AI systems that we work on, the AI systems that we build, will not destroy us, because they could. Let me give you an example of alignment gone wrong. Consider an AI system trained to help a package delivery company to optimize its routes and delivery times. If the objective of this AI is to maximize successful deliveries while minimizing delivery time, like this is the stated objective, this is what it's told to do. At all costs, maximize successful deliveries, minimize delivery time. On the surface, this sounds like a very well aligned prompt. It sounds very straightforward. It sounds like something that the AI can understand and do. And the AI system, interpreting this objective literally, decides to route delivery drivers through residential areas at unsafe speeds to minimize delivery times. The same AI system decides to recommend that drivers skip rest breaks to maintain a higher delivery rate. Who needs sleep? We have to maximize these deliveries in a minimal time. Why are you sleeping? The same AI system could then suggest that, how about instead of stopping to deliver the package, you could just drop the package off a moving vehicle to minimize the time spent per delivery. Technically, this would be achieving its objective. It could then prioritize easy to reach addresses and then deprioritize the elderly and the infirm, because those guys, they may take too long to come and pick the package. Like, the guy may have to park and then he rings on the bell and then the lady's like, "I'm coming, hold on," as she shivers her way towards the door, and the AI overload doesn't like that, because it goes against its principle, which is to maximize deliveries and minimize delivery time. That's alignment gone wrong. Let me give a real-time example. In 2016, Microsoft released a chatbot called Tai, T-A-Y. It was released on Twitter. Tai was designed to engage in a casual and playful conversation with users, like while learning from their interactions to improve its responses. Now, within 24 hours of Tai's launch, Tai began posting offensive, racist, and inflammatory tweets. I mean, if Tai was learning from Twitter and from its interactions with the people on Twitter, I can't blame it. Twitter is a crazy place. But what went wrong here? One, Tai lacked relevant safeguards. Tai was designed to learn from user interactions in real time, but it lacked robust safeguards to prevent against harm and inappropriate behavior. But that's alignment. Alignment needs to be solved before all else. Before we get to ASI and AGI, which I'll get to, don't ask, I'll get to that. We need to solve alignment. We need to make sure the systems that we're working on, we need to ensure that the things that we're pouring all our brain power into perfecting don't nuke us, because they could. Let me talk about AI agents. The concept of AI agents has been around since 2001, since 1999, when the year The Matrix got released. One of the most popular characters in that movie was Agent Smith. So when the ChatGPT moment happened and then everyone was freaking out about AI, the word agents picked up a bit. And if you haven't heard of it yet, you're hearing it now, and you're going to hear a lot more of it this year. An agentic system is one that utilizes the raw intelligence of AI models and the function calling and tool use abilities of the more advanced AI models to accomplish a goal by breaking it down into lots of tiny tasks and going task by task in an infinite loop. Let me break it down some more. Let's say you tell an AI system, send an email to my boss saying I quit. This AI will first have to find out who your boss is, assuming it doesn't already know that. 2, find the appropriate mailing system that it has to use for this. 3, draft out the email. 4, check the email so that it's perfect. And 5, send the email. So this agentic system is going to start working in a loop, doing task by task, all aimed at the final goal of sending your boss the email that you're quitting. That's agentic systems in a nutshell. There's so many agentic systems that are available right now. Actually, there's one that I use literally every day, all the time. It's crazy. I've grown so reliant. It's ridiculous. But I don't want to get into that right now. That's another can of worms. I'll make another video for that one. But that's the general gist for agentic systems. Now, let me clarify this. An agentic system is not an AI model. The AI model is the underlying brain behind the system. So you can switch out these models. A good agentic system gives you the ability to change the model that is running the system. Let's talk about the future of AI. If you've reached this point in the video, then you have a general understanding of the current state of AI systems. There's just raw models. They are good at certain things, they are bad at certain things, they need specific instructions, they fail very simple questions, and then they pass very complex questions. It's very crazy. One word that keeps being thrown around in the AI community is AGI, which is Artificial General Intelligence. This is the holy grail of AI. This is a single AI system that is able to reason across all general tasks, that is able to learn new skills on the fly and implement them just like a human can. AGI is tricky. For one, researchers can't even decide on what AGI is. They don't know. They don't know when they will know that it's AGI. Consequentially, so many different tests have come up to find out if AGI has been achieved. The most popular one being the ARC-AGI test, which is basically a $1 million bounty for whoever creates AGI and manages to pass their test. Though recently they are facing some scrutiny because they publicize their tests, and most of these AI companies are training their models off their tests. It's basically Kasasi. So like the model comes and it already knows most of the questions. It's ridiculous. But generally speaking, AGI, once AGI is achieved, it will usher in a new age of unemployment. Currently so many jobs are being taken by AI, but when AGI is achieved, whichever company implements AGI fully, and it is undeniable that this is AGI, one, that company will make a lot of money, for one. Two, that company will be in a position to replace a lot of humans. Like a lot. Basically every human in the company can be replaced by that AGI. That's why it's such a gold mine. The next couple of minutes are going to be a bit wild, so strap in. But picture this. A company achieves AGI. It's basically a digital brain that works as good as a human brain. And then another company achieves advanced robotics, a robotic body that moves as well as the human body does. So if these two technologies merge, you basically have a robot that works as efficiently as a human, but doesn't need to rest, doesn't need to sleep. Every single business would want that. They would want a mind that's able to do their accounting 24/7. They would want someone in the factory that's able to work all night at getting those Nike shoes finished. So many people would lose their jobs once these technologies are perfected. When these technologies are perfected and so many people are losing their jobs, governments all over the world are going to have to scramble and put together what they call a universal basic income. Basically, everyone just gets a bare minimum paycheck to stay alive because they no longer have a job. Still with me? Okay, now, I know that such a view of the world sounds a bit pessimistic. But no, I'm stating facts as is. This is where we're heading. A way to prepare for this is arm yourself with skills that will keep you relevant as these AI technologies get better. Keep yourself educated about the latest in AI tech by subscribing to my channel right now before I slap you, and learn something useful. Learn a talent, a skill, not the stuff that you studied in school, because that's going to be useless in a bit. Learn something useful, something with which you can give value to the people. Bonus points if it's something that can be enhanced using AI and or robotics. So if it is art, good. Perfect your art and figure out a way of infusing AI in there. If it is coding, oh, you're on the right track. There's so much AI in coding, it's ridiculous even. If it is music, then do your music and pour your heart and soul into it, and do that. Just learn something new, but keep yourself up to date with AI technology, because it's the future and it's going to change everything. Similar to how no one knows what lies within a black hole, what is at the singularity, at the center of the black hole, no one really knows what will happen when AGI is achieved. That's why it's called the singularity. It could be good, it could be bad. It will most probably be bad for a lot of people and good for some few people. It's a sensitive topic. I don't think I can do this topic justice, but I have explained it to you to the best of my abilities. That's AGI. It's coming. I'm quite sure AGI is going to be achieved within the coming 2 years. At this rate, at the rate of AI progress, within the coming 2 years. So that puts a timer. You have 2 years to figure out a way that you're going to use this AI technology boom that we're in to do something about it. Just do something that will keep you useful and relevant when AGI comes. Yeah, sorry. It got too deep there. Now ASI is what comes after AGI. Yeah, you thought we were done? Nah, bruh, we're not done. ASI is artificial super intelligence. Super being AGI is a computer system that is as smart or as intelligent as a human being. It's able to generalize and do tasks the way a human does, or at the level of a human being. ASI is AI systems that are beyond human. So, super intelligence. Take that as you wish. Whatever you're imagining, times 10. Now that, times 10. That's ASI. No one really knows what it will look like. It will probably be an API. Later on it will have a robotic body. But yeah, welcome to the realm of existential dread. You have now been burdened with this knowledge. It's coming, and it's coming fast, and it's coming hard. This technology is revolutionary. What I've just described is coming, and when it does, it's going to usher in a whole new age of humanity. Let me give you an example, and this is right now. Google DeepMind has a model called AlphaFold, which is able to predict the nature of proteins. Proteins, the things that make up your body and every cell in the world. This includes disease cells, animal cells, and that is it as it is now. In about 3 years, I predict that AlphaFold is going to be able to just generate solutions to diseases. Just shoot a wonder drug out of its butt, just like that. Because that's what it does. It is able to build proteins from the ground up. That's AlphaFold. Now imagine an AI model that is trained to build new materials. Psych, don't just imagine it, it's already there. These models that just churn out revolutionary new material combinations. And all a scientist has to do is experiment with this new material, and just like that, we could have a material that is heat resistant enough to usher in a whole new era of rocket engines. We could have a material that is a whole new type of fuel, so that countries no longer have to rely on coal or on uranium. No, an AGI could think of a material that serves as a nuclear fuel that is non-radioactive. Actually, one of the holy grails in the physics community is called nuclear fusion. It's just, I just got shivers right now just thinking about it. Cold nuclear fusion would be a game changer. Imagine never having to pay your electricity bill forever. Nuclear fusion is, boy, I'm about to start talking about physics now. Okay. Nuclear energy can be generated in two possible ways. There is nuclear fission, which is the splitting of an atom. So this is an atom, like say uranium, then it splits, and then when it splits, it releases a lot of energy and a lot of neutrons. These neutrons and the energy that is released causes a nearby uranium atom to also split, and the next one also splits, like that. That's nuclear fission. That's how nuclear bombs work. That's how nuclear reactors work. So you see those big silos with like smoke coming out of them. In there is uranium and other radioactive chemicals being used for these nuclear fission processes, and there is some rods in there that they use for absorbing all those extra neutrons to prevent a runaway nuclear reaction, which is how Chernobyl happened, by the way. It was a runaway nuclear reaction that just made the whole thing explode. So that's fission. It's the splitting of an atom. Nuclear fusion is the fusing of atoms. It's in the name, fusion. The joining of atoms, and it generates about 4 times as much energy as fission. So you know that one fission bomb, a fusion bomb would be that, but like times. You know that big ball of flame that's at the center of our solar system and has like held the whole solar system together for thousands, millions of years, and like lots of religions have come up worshipping it. You know, the sun, it's powered by fusion. That's how it's been ablaze for all these years. That's nuclear fusion. Fusion has a lot of potential as a source of energy, but the problem is the requirements for fusion to happen are ridiculous. One, you need a lot of gravity, there has to be something forcing these atoms to join, because atoms don't like to touch. It's the law. Second, you need a lot of heat. Like, it is a very heat intensive process. Actually, the heat that it takes to kickstart a fusion process, it takes a while for that heat to be negligible compared to the heat you will get out of the process. But the potential energy rewards of fusion are just ridiculous. Cold fusion would be that, but minus the needed heat, minus the initial fission explosion to kickstart the whole thing. And if we could pull that off, cold fusion, it would usher in a whole new age of renewable energy. It would even be ridiculous. There would be so much energy you would not know what to use it for. Electric vehicles would be the thing. You would have infinite energy. The only other way of having as much energy as nuclear fusion would accord us is if we could somehow do a Dyson swarm. A Dyson swarm would be very cool. Yeah, so you know that future that they show of like flying cars and like drones everywhere and like the Jetsons? Yeah, that would only be possible with nuclear fusion, called nuclear fusion. And this could be done by using research that is done by a super smart AI. Okay, so that's all I had for you today. Thank you for watching. If you found the video insightful, like, share, subscribe, and do a backflip in that order. I'll see you next time. Bye.